Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 210, course schedule 2. There are a total of number of courses you have to take, labeled from 0 to number of courses minus 1. You are given an array, prerequisites, where prerequisite I equals AI BI indicates that you must take course BI first if you want to take course AI. So which means BI is AI's dependency. For example, the pair 0, 1 indicates that to take course 0, you have to first take course 1. So the order should be first take course 1 and then take course 0. That's what the pair 0, 1 means. Return the ordering of the courses you should take to finish all courses. If there are many valid answers, return any of them. If it's impossible to finish all courses, return an empty array. For example, in the example 1, the input number of courses is 2, prerequisite is 1, 0. The output is 0, 1. So there are a total of 2 courses to take. To take course 1, you should have finished course 0. So the correct course order is 0, 1. For example 2, number of courses equals 4. Prerequisite 1, 0, 2, 0, 3, 1, 3, 2. The output is 0, 2, 1, 3. There are a total of 4 courses to take. To take course 3, you should have finished both course 1 and course 2, that's indicated by this one. Both course 1 and 2 should be taken after you finish course 0. That's indicated by the pair 1, 0, 2, 0. So one correct course order is 0, 1, 2, 3. Another correct order is 0, 2, 1, 3. Either of them works, so you just have to return one. In the example 3, the number of courses is 1. Prerequisite equals empty. So in that case, you just take that one course. So that's kind of the problem statement. So the method to solve this one is actually the topology sort. So I will just explain this algorithm as I'm coding it. So first, when we deal with this kind of dependency pairs, so in the prerequisite, it will be pairs, and then each pairs indicates what dependency. Let's say, let's take a look at example 2. So for course 0, the dependency for course 0 is for the course 1. The dependency for course 1 is course 0. So you have to first take course 0 before you can take the course 1. And similarly, you have to first take course 1 and then you can take the course 2. So in that case, usually we want to represent this prerequisite using an adjacency list. In the adjacency list, so we have each course, and then also for each course, we want to know what are the next courses I can take after finish that course. So that's kind of the use case for adjacency list. So let me have adjacency list equals, let me utilize the dictionary to represent that. So basically for that one, it's a dictionary of list. So for this dictionary, the key is each course, and then in that, the value is a list of all the next courses you can take after you finish this course. And then we also want to check so how many dependencies each course have. So in that case, we call it integrate. So for this integrate, it's also a dictionary. The key is each course, and then the value is the number of dependencies you have to finish before you can take this course. Or in this scenario, we call it the number of prerequisites you have to finish before you can take this course. And then we are going to fill the value for adjacency list and the integrate. So basically for the prerequisite and for the course and the prerequisite, in the prerequisites. So remember, in the given prerequisites, it's given, for example, for the first value in this prerequisite, it's 1, 0. It indicates that you need to first take course 0 before you can take course 1. So in that case, the course is 1, and the prerequisite for course 1 is the course 0. So adjacency list prerequisite dot append course. So basically, this adjacency list is keeping track of the courses for each prerequisite. What are the next course you can take after you finish this prerequisite? And then integrate. So in this case, we know that, okay, for this course, it has 1 prerequisite. So we increase the integrate by 1. So increase the number of prerequisites by 1. That's kind of how we construct the adjacency list. And then let's utilize a queue. So what's in this queue? So initially, we want to put all the courses without any prerequisite into the queue. That's kind of like the starting point. If we want to print out the order of courses to take, I mean, the first in that list, or the top one, is the course without prerequisite. You have to first take these courses. So in that case, that equals course for course num prerequisite in integrate dot items. So okay, so in this case, since we are utilizing a dictionary to keep track of the integrate, so in that case, it's more like, okay, I for I in range num courses. So since each course, if number of courses equals 4, then all the course is represented by the value from 0 to num courses minus 1. So that's why we utilize this to keep track of the courses. Okay, if I not in integrate. So this means that, okay, we first get all the courses without any prerequisite. That's the initial value of Q. And then while Q, we first pop the course from the Q. And then after take this course, we can move to the all the courses that's depend on this course. So basically, after takes this course, we can move to the courses that has prerequisite that the prerequisite is this course. So basically, it's the next course we can take. For in that case, we remove the dependency. So, which means, okay, currently we are looking at this course. We call it course, and then we check out the next courses. For the next courses in this adjacency list, we just decrease the number of dependencies by 1 because we already finished one of the dependencies or one of the prerequisite. So in this case, we decrease the number of prerequisites for these next courses by 1. If in degree next course equals 0, so if after we finish this prerequisite, if the next courses does not have any other prerequisite, which means the in degree of next courses equals 0. In that case, we add them to the queue. Remember, we also want to print the order, so let's use a list result. So basically, every time after we pop from the queue, we just append it to the results. So let's run the code. Okay, we failed one test case. Let me check why that's the case. Okay, so we first construct the adjacency list, and then we keep track of the number of prerequisites for each course. So for course and prerequisite, in the prerequisites, so prerequisite I equals AI BI, that is course, and then it's and then the prerequisite of that course. So for a course and prerequisite in this prerequisites, adjacency list prerequisite dot append course, and then we increase the number of prerequisites for this course by 1. And then initially for this queue, it contains I for I in range number of courses if I not in degree. So which means at the very beginning, this should contain all the courses without any prerequisite. So in this case, the expected value is 0. So course 1, the prerequisite of course 1 is 0. If X So the only thing I can think of where went wrong is this queue. Initially, it should not have the anything. So this queue should be empty. So let me try to walk through the execution for this one. So adjacency list prerequisite. So in this case, list 0 dot append 1, and then two append 1 adjacency list 1 dot append 0, and then integrate should be the integrate 1 Oh, I see where I did wrong. So I cannot just simply return results because the result could still contain the courses. Let's say in this example, course 2 does not have any prerequisite. So I mean, if following the logic of my code, I could add this course 2 into the results. However, I cannot complete all the course, so I need to keep track of the number of courses completed. So num completed. So error beginning issue equals 0. So as I can complete one course, I need to increase the counter. So, and then in the end, I need to keep track. Let's say if I can complete all the courses, if number complete equals the num of courses, in that case, I return results. Else, I just return empty list. So let me run the code. Okay, cool. So this is our solution. So let me go over this solution from the very beginning. So basically, we first construct the adjacency list to keep track of the next courses you can take after finish this prerequisite. So basically, it's a dictionary of lists with key is prerequisite, and then the value is the courses you can take after you complete this prerequisite. So that could be a list of courses. Let's say, for example, if after you finish this prerequisite, you may take more than one courses as next courses. And then integrate is keep track of the number of prerequisites for each course. And then initially for this queue, it contains the course without any prerequisite. That should be the starting point. Remember, when you want to figure out the right order to take all the courses, you want to start with the course that without any prerequisite. So those introductory courses without any prerequisite should be the starting point. And then we use as a result to keep track of the order of the courses you are taking. And then we also want to keep track of the number of courses you can complete. So for example, as we keep track of the construct the list of course you can take, maybe we are interrupted halfway through it. And then this result may already contain some courses. That's the mistake I made. But in that case, you still cannot finish all the courses. So in that case, if you just simply return this result, you would get the wrong answer. That's why we need additional variable to track if we can complete all the courses. So if you can finish all the courses. So in that case, as long as the queue is not empty, we pop the course from the queue. So remember, the queue only keep track of the courses without prerequisite or all the prerequisite has already been finished. So as long as we finish all the prerequisite for one course, we add that course to the queue. So now we pop off that course from the queue and then we append it to the results because we can take this course right now since we already complete all the prerequisite. And then we increase the number of courses that we have completed by 1. So one more course we completed. And then we just check all the next courses we can take after finish this course. So for next course in the adjacency list of this course, for all those next courses, we reduce the number of prerequisite by 1, which means that, okay, since we already complete one of the prerequisite, which is the current course, so that's kind of why we reduce the number of prerequisite by 1. And then after that, if we find if any of the course with all the prerequisite already completed, which means in degree of that next course equals 0, in that case, we add that next course to the queue. We only add the courses to the queue when we finish all the prerequisite of that course. And then in the end, we check, okay, if the number of courses that we finish equals to the total number of courses, we just return the result. Otherwise, we return the empty array. So that's kind of the solution to course schedule by utilizing the topology sort. So it's very important method, I would say, algorithm for graphs. And then for this one, I mean, if you do not know the topology sort, it's not super easy to figure out. But once you understand it, you can apply this to other problems as well.